0. Okay, I am going to do another example on how to use the squeeze theorem, and I'm going to show you that no matter how large the values are, you could still use the logic in the squeeze theorem to find out what it should be. Basically, here is the problem I'm going to do. The limit as x approaches 0 of x to the 100th power times sine 150x. Now basically, as I said in the last one, sine, as with other identities in trigonometry, will always be oscillating between the values of 1 and -1. So, knowing that knowledge, you can say that -1 will always be less than or equal to, once again we are isolating the sine part, sine 150x, which will always be less than or equal to 1, because it must always in between, sine 150x must always be in between its lowest and highest values. Now, to make this value equivalent to the original problem we have, because they have to be the same, we must multiply each piece in the problem by what's left in the problem, which was x to the 100th power. So, let's do that, and we get negative x to the 100th power is less than or equal to x to the 100th power sine 150x, which is less than or equal to x to the 100th power. Now, knowing that, and that our limit is x as it approaches 0, we can substitute 0 back in. When you put 0 to the 100th power, you get 0, which is less than or equal to 0 to the 100th power sine 150, 0, which is less than or equal to 0 to the 100th power, which is once again 0. Since your lowest value and your highest value are equivalent, you cannot have any values, or since this must be greater than or equal to 0 and less than or equal to 0 at the same time, it must be 0, because you cannot have a value that is greater than 0 and less than 0 at the same time. Using this logic, you can find that the limit as x approaches 0 in x to the 100th power times sine 150x will always be 0.